record. Okay. So compared to the last worksheet, I didn't really get, I got a couple questions about it, like a couple people emailed me and I had a couple Zoom meetings, but for the most part, no one really asked a lot of questions about this. So I was just gonna kind of go through how to enter it in SPSS, but before we get started, what sorts of specific questions do you have about this worksheet?
When you say to do a graph with error bars, how do you do that?
Yeah, that's a great question. So, and I haven't looked at your worksheets yet, so I don't know what sorts of problems are consistent in the worksheets yet. But whenever you make a graph, let me get my board. Remember that standard error is representing variability, okay? So standard error is showing variability within, say, a level of your independent variable. So if you have a graph, whatever your graph is, and you have your bars, whatever they are, right? So you have something like this, okay? So standard error bars in bar graphs and in line graphs, really, they look like this, these little eye things that I just put on the top. And of course, they vary in size and shape depending on how much variability. And so what the bar is showing is the bar is saying, okay, here's the mean, right? This is the mean of this level. And what the standard error bars are saying is they're showing how much variability there is. So if you have a standard error bar that's, say, you know, something like that, I mean, that's a lot of variability, right? So it really just gives you information, kind of like the standard deviation does, where it just tells you how much variability you have in your given sample there. And standard error is meant to be an estimate of how far away the mean is from the possible population mean. So it just gives you more information. So that's what I'm talking about whenever I'm talking about doing standard error. Did that help? Okay. What else? What are some other specific questions before we get into this?
Can we talk about the APA format again?
Yeah. Okay. Was that what you were going to ask, Grace?
Okay.
Okay. All right. I have had, I think it was Claire, is she on here? Was asking about that also. So, hang on, let me pull up the worksheet that is, and I'm gonna post the key to the worksheet too. So that will be helpful. Okay, maybe I'll just do this. Maybe I'll just share. Let's share. Okay, do y'all see the worksheet?
Mm-hmm.
Okay. Okay. So APAs, okay. So here's your chart. When we go through this, we'll do this, but so here's your chart, the important chart for the ANOVA. So we have our sums of squares, we have our degrees of freedom, and then we have our mean squares, our Fs, our p-values, and our eta squared. So this line here is your main effect of gender. This line here is your main effect of alcohol. And this is your interaction. Right? Because here we have a 2x3, right? 2x3? 2x3 design. So we have two main effects and one interaction possible in this design. So when we write that main effect, for example, the main effect of sex, when we write it in APA format, we're going to look at this line here to write it. And so here we have F, and then in the parentheses, you're going to put the degrees of freedom for gender, right, which is 1, because we have 2 levels there. So the degrees of freedom is 1. And then you're going to put the error, which is not on this graph. It was on SPSS, because there's the error, and then there's the corrected total and the total. So you're going to use the error degrees of freedom for the second spot. So it's F1, comma, 42 equals, and then here's your F, and then comma, and then there's your p-value, and then comma, and then you'd put your, this is a symbol for eta squared, and then you do the eta squared. And I'm going to talk about that in a PowerPoint. But essentially, for those of you that's maybe looked at the PowerPoint before I do the lecture, essentially what effect size tells you is how much effects in your model this variable has. So this is saying that out of all of your variability, that's weird because it never adds up to 100%, but this is saying that out of your design, that about 5% of the variability in the design is due to your manipulation of gender. And then this is saying that about 50% basically of the variability in the design is due to your variable of alcohol. So what this is saying, and this is saying that this isn't significant, but these two are. And so, and then if you look at the interaction, right, it's 36%. So this is saying that your independent variable of alcohol was more powerful. It had a larger effect than gender and than the combined did. And again, I'm going to post a PowerPoint about that, but that's what effect size is saying. So then when you write it out, so here's the F, right? So you can do this a couple ways, but this is what I'm talking about when I'm talking about APA format. And then how would you interpret it? Well, there's not a main effect, right? Because it's not significant. So there's not a main effect of sex, and then you could say males, and then you put the mean and standard error, which would be found in your descriptive stats on SPSS after you mention the variable. Males and females rated the attractiveness of the people that they were chatting up similarly, because there was no significant difference. And then here's how you would do it with alcohol. So alcohol here, and so 2, again, 42, you put it all over the same error term. And then here's your F, your p-value, and your eta squared, which is wrong. It's this. Yeah. Oh, cat. Sorry. Okay. Does that help?
So the 42 is the error?
It is. It's the degrees of freedom associated with the error.
When we scroll down and look at the graph,
Yeah. Oh, I guess I didn't do one. I'll add one to this answer sheet though. I'll add that, sorry. It would look something like, let's see, they were between, right? Yeah. Let's see, you had like 4 pints 2 pints and whatever, 0. Let's see. I'll create something real quick without having the exact data. Male. I don't know what the, remember. Whatever. Is that backwards or is that regular? Oh, wait. Forgot the standard error bars. You can do it like that.
So
You could switch this, like you could have had the alcohol here just 2 bars and had male and female. That would have been fine too.
Could you explain why you chose bar instead of line?
Yeah. Oh my God. Trey. Ugh. This is my cat Trey. He's a jerk. Not really, but okay. So for this one, variables are between, right? So I chose a bar graph because the variables are between.
Okay.
Yeah. What else, guys?
One other thing that I've noticed is, so when you go up back to the table that you put in for number 2, my numbers are just slightly off than what you have.
That's okay.
Okay.
That's okay.
Okay, but I had the same significance for the results, so I was just making sure there wasn't anything.
Yeah, there's lots of reasons for that. I mean, when I made this answer sheet, I could have had a typo in the numbers. I mean, you enter one of these numbers in wrong.
Yeah.
And you're going to get different numbers. Yeah.
Okay.
So it could have been either I entered in something different or you entered in something different than what's on here.
Okay.
So you use a line graph when the variables are with that, right?
Yes. Mm-hmm.
When we're interpreting the interactions in towards the end, do these results tell us what the interaction is or just that there is an interaction?
It just tells you that there is an interaction.
Okay.
That's all the ANOVA table tells you.
Okay.
And so interactions can be really difficult to interpret. So when you just have a 2-way interaction like this, right, you really have to look at the means and what the means are. And there should be a chart on there that tells you about the means. And you really have to just think about it and determine, based on the means of each of these, what the interaction is telling you. And a lot of it is going to be driven based on your hypothesis. Like, what do you think is going to happen, right? Because whenever you added these 2 variables for a reason, because you think that they both have an effect, and you probably have some prediction about the interaction. Sometimes it depends on your project, right? You might not even care about the interaction, but most of us do. Like, most of the time you want the interaction to be significant. So like, for example, in my experiments, I might have cocaine and then I might have like a D2 antagonist. And I introduced the D2 antagonist because I think it's going to affect their response to cocaine. So I think that these two are going to interact, these two variables. And I might think that it's going to do something different in males versus females or something like that. So that's going to be like a three-way interaction. So it can be tough to interpret. For this one, interaction. So for this one, while attractiveness is important, charismatic men were more likely to be rated higher than attractive men. In other words, charisma was more important to the women in the study than attractiveness. So both of them mattered, and they did interact, right? There was an interaction here for the looks and the charisma one. So it means that both are important, right? And that, of course, attractive, charismatic men got higher levels of attractiveness, right? As one might expect. So that's how these are interacting. Yet, whenever you look at the interaction, it does seem that charisma was holding a little bit more water than attractiveness. So if you were charismatic, your looks didn't matter as much. Like, it was helpful, but having charisma was more important.
Okay, so the actual ANOVA results just tell us that there's an interaction, but we can figure out that interaction by looking at the means.
Right. Mm-hmm.
Okay.
Yeah. All right, what else? Do you guys want to run it? So this has been going for 24 minutes. As you know, this cuts off at 40 minutes. Which one of these would you guys prefer we do? Like, which one gave you the most trouble? Or I could do this. Since it might cut me off, I could just film a video of me doing both of these, and I'll post it on YouTube. Would that be helpful?
Yes.
For the first one, can you include some of you entering the data? Because for the ones where we need to rearrange the data, I just want to make sure that that's like, for sometimes like I would have to run it and it would say like I can't run it that way and I'd have to rearrange it. So I just want to make sure I'm entering it correctly.
Yeah, sure, that's totally fine. So I'll do this one then. I'll do this, the between one, the pints and the females. I'll do this one for this video, and then I'll post a video of me just doing both of them for YouTube. Does that work? Okay, cool.
Can I ask really quick how the SPSS quiz will be formatted? Is it like one of these worksheets?
It's going to be very similar to this.
Okay.
This is the basic idea. I mean, I could go ahead and show it to you if you want. I haven't looked at it to see if I need to change it for the format of this class. So it could change a little, but I mean, let's see. Oh no, I might not have a blank one. Oh. Let's see. Is this it? Okay, so this is what, share. Okay, do y'all see it?
Yes.
Okay, so the way this worked last time is that I had a data set on Moodle. And of course we did this in class last time, but so you'll have this, and it's just asking general things. Here's the scenario, independent, dependent variables. It tells you how much each question is worth. What's the design? What post-hoc test would you use? And then it tells you to open the data set in SPSS and run it. So the data is already entered for this one. And then for the quiz. And then you draw a graph, you report the findings, you interpret the findings. And I'm going to post a video about effect size and power, and then I have a question about that. So this is a question about effect size, and this is a question about power.
Do you mind if we use SPSS to make the graphs, or do you want us to use Excel?
It doesn't matter to me.
Okay.
However you want to do it is fine. It does not matter. If you have like a preferred way to do graphs, that's totally fine.
Can we draw them, or do you want them to be exact?
Aw, puppy Will.
Oh,
Yeah, they don't have to be exact.
Okay.
I'm looking for concept. That's what I'm looking for. I'm looking for your ability to say, this is how the graph should look.
Okay. And the other thing I wanted to clarify, I think it was in the Slack, you mentioned that they would be due Sunday night, and then on the YouTube, you said Monday at 5.
Oh, did I say Sunday? Let's see where on the Slack. Sorry, I'm not trying to be weird. What did I say in the email?
I think maybe it was the email, not the Slack.
Oh, okay.
I think the email, it was Monday,
Oh, then I just,
but I also could have read that wrong.
Whatever I said in the email is what I meant. Where's the email? Sent items.
It was Monday.
Inbox.
Okay.
I always send myself a copy of these things. When did I send that? Oh my gosh, so many Rice emails.
it does say Monday. Sorry. That was-
Okay. Yeah. So I'll get those to you today by 5, and then you'll have the weekend. And again, you'll have, you know, every open note, open book, your friends, and the exam will be like that too. I'm sending you with the exam. So you guys could work together. You could use your notes, and you can ask me questions too. I mean, my goal ultimately, I mean, I want you guys to understand this stuff. Like I want you guys to feel comfortable using SPSS, and it's almost impossible in this, you know, this way, but I mean, that's my goal for the course. I want you guys to feel comfortable with stats, understand it at least a little bit, and feel comfortable running some basic stats. And ANOVA's not even basic stats. I mean, this is real stuff. So that's my goal, and I'm happy to help, especially with the quiz. I'll help you with the exam too, but I'll be a little bit more reserved in my help for the exam, but I'll help you with the quiz. So. And I'm sending them both out together. So, and that's how the exam's going to be. The exam's going to be very similar to the quiz and the SPSS quiz.
And I assume the exam is going to include everything from when we were on campus.
Yes, it will. It's a lot more stats heavy. It will have some things from the past, but it's really mostly because it just all builds on each other.
Okay.
You know, if you don't understand independent and dependent variables, you're not going to be able to understand what, you know, ANOVA and what ANOVA to run. And, you know, so it kind of all builds. But yeah, I would review that information. Don't spend a ton of time, but, you know, go back through and I might have a couple multiple choice questions going back to, you know, what science is. So be sure to review like what empirical is, but you're going to have open notes. So.
Okay.
So that kind of stuff, but you know, you just go back to your notes. And I'll have all the PowerPoints, but once I do a PowerPoint on effect size, and then I'll do one on confidence intervals and power. And that's all the information for the class. I normally go over writing, but we got to cut something. So writing will get the cut. In the future, I will say this. In the future, if you guys find yourself needing to write something for like a 350 project, I am happy to sit down and talk to you guys and help you guys and read drafts and stuff like that for APA format and all of that, since we didn't get to go over that. So let me know if I can help. for sure, for real. I like writing. I'm a dork. All right, anything else before we get into this SPSS stuff? No? Okay. All right, what screen do you guys see? What am I sharing?
The quiz.
Okay,
Now SPSS.
okay, cool. All right, so here we have our SPSS. So we would go to variable view. Trey, this cat, I swear. Okay. Okay. So here in our variable view, because we have two between variables, we would have gender, we'd have alcohol, and we'd have attractiveness. Right, those are our variables. Okay, so we have our two independent variables and our dependent variable. So I'm going to take it down because I don't like decimals. If you like decimals, that is your prerogative. So gender is what kind of variable?
Nominal.
Good. Alcohol, what kind of variable is it?
Scale.
Right.
Alcohol?
Well, no, not nominal. Or yeah. Okay. Cool. Yeah.
And attractiveness, what kind of variable is that?
Scale.
Mm-hmm. Good job. Okay, so let's go to values. So we do this and we would designate, say 0 as female. Does that box come up? Do you guys see the value box? Okay, so we do like, and 1 is male for gender. And then we come over here, we would do 0 for 0 pints. Can I do spaces? Yay. 1 for 2 pints. And then 2 for 4 pints. Those are the levels, right? What questions do you have about this?
If you didn't put values in, like I just put 0, 2, and 4 in for the pints, is that gonna affect it or is that still fine?
Oh, if you didn't do this over here?
Yeah, like I just put, instead of actually having values, I just said 0, 2, 4, like when I was entering it in.
I think it would still work the same. This just designates what your labels are. It would still treat them as separate categories.
Okay.
I'm pretty sure. I'm pretty sure it's fine.
Yeah, because I think I got similar numbers in the end, so I'm assuming.
Okay, if you got similar numbers, then you're good. Then it did it just fine. All right, so then your SPSS would look like this, and you would do the data just by, let's see, 1, 2, 3, 4, 5, 6, 8. Yeah, so you'd have like, so we have our first group is female. We have 8 females and they had no alcohol. That's how you designate they were female and they had 0 pints. And then you enter in, let's see, 65, 70, 60, 60, 65, 70. Let's see. Where's the worksheet? Okay. And then next we have males who've also had 0 pints. And we have Does that make sense? So that's how you do that. And you would do that throughout. So then we have it like 8 more females. How much time we got? What does it say? 2 minutes. Okay. We have, no, it's alcohol. I wonder if I can enter all this in. But I can. Challenge accepted. Let's see. Oh, awesome. Okay. So here's our data. And then we go over here to analyze. And we go to, do we choose univariate or multivariate or repeated measures?
Univariate.
Very good, because we have one dependent variable. So we go to univariate and we put our dependent variable over here in the dependent variable. And then we put these in our fixed factors. And we come over here to EM means and we move all these over. So so we'll get the means for this. Pair main effects. LSD is fine, but it gives you the option for Bonferroni over there too. And then let's see, do we need anything else? We could do descriptive stats and estimates of effect size. And then that's it. So let's do, okay. All right. Output. Okay, you guys see my output screen?
Yes.
Okay. So then these are our means for each of these values. And then here is our box. And then here's our error, our interaction, and our main effects. So you don't ever have to worry about corrected model, the intercept, the total, or the corrected total. It's just these 4 here. And then here's your grand mean. And then here's your main effect of gender. And there's the pairwise comparisons here, comparing the two.